through projects. In this video, we are going to explain about the project title Object Detection of Remote Sensing Image based on Multi-Scale Feature Fusion and Attention Mechanism. Before diving into the execution, let me give you an overview of the project. The project aims to enhance the process of identifying and locating specific objects within images captured from a distance, known as remote sensing imagery. Remote sensing entails gathering data using satellites or aircraft and finds application in various fields like agriculture, urban planning, and disaster management. Object detection in remote sensing involves precisely identifying objects like vehicles, people, buildings, roads, and more within these images. By improving object detection techniques, the project seeks to enhance the accuracy and efficiency of extracting valuable information from remote sensing imagery, benefiting applications across multiple domains. This project aims to improve object detection in remote sensing imagery by addressing challenges like varying object sizes, complex backgrounds, occultations, and resolution differences. Our goal is to enhance the accuracy of detection algorithms, benefiting applications in environmental monitoring, urban planning, and disaster response. Traditional methods for object detection in remote sensing imagery rely on handcrafted features and machine learning algorithms, but struggle due to the complexity and variability of objects in these images. They often fail to capture context information or adapt to different scales, resulting in lower accuracy and robustness. The proposed system investigates different versions of YOLO V5 for detecting objects in remote sensing images. Some versions combine information from multiple scales to improve detection accuracy, which are YOLO V5P2, YOLO V5 DSI FPN, while others prioritize important areas of the image using attention mechanism, which are YOLO V5 MSC, YOLO V5M ECA, YOLO V5M CBAM. By evaluating these variants, the project aims to determine the best architecture for reliably and accurately detecting objects in remote sensing applications. We compare the performance of different YOLO V5 models using metrics like mean average precision MAP, precision, and recall to determine the most effective model for accurately detecting and localizing objects in remote sensing imagery. The project improves how we spot objects in remote sensing images by combining multi scale feature fusion and attention mechanisms. This benefits various groups like researchers, government agencies, industries, environmental organizations, and emergency responders. With better accuracy in detecting objects, decisions can be made more effectively and resource managed more efficiently. This has wide ranging applications including environmental monitoring, disaster management, agriculture, and wildlife conservation, where precise and timely information is crucial for decision making and response strategies. To implement this project, we need software and hardware requirements. Hardware requirements of the project are operating system of Windows, processor of 5 and above, RAM of 8 GB and above, hard disk of 25 GB and above. Software requirements of the project are application is Anaconda, primary language is Python, front-end framework is Flask, back-end framework is Jupyter Notebook, database is SQLite 3, front-end technologies used in the project are HTML, CSS, JavaScript, and Bootstrap 4. Algorithms used. These are the algorithms which are built in the project for object detection of remote sensing image. So the algorithm which is performing best will be deployed in the front end. So here these are the different versions of YOLO V5, which are YOLO V5M, YOLO V5 MSC, YOLO V5 MECA, YOLO V5 MCBAM, YOLO V5 P2, YOLO V5 DSI FPN, and YOLO V5 X6. So let me explain you what YOLO V5 is. YOLO V5, or You Only Look Once version 5, is a cutting edge deep learning model specializing in real time object detection. It excels at both speed and accuracy, making it ideal for tasks like self driving cars and video surveillance. YOLO V5 prioritizes user friendliness and offers diverse pre trained models for various needs, while also allowing for customization for unique objects. Overall, it's a powerful and versatile tool for object detection in numerous real world applications. Now, let us execute the project. To execute this project, first we need to open the code folder which contains the project source code files. So here we have the sample folder. In this folder, we are having the test cases which we will use during the execution. This is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap. This is the templates folder. This folder contains all the HTML pages used in the project. It includes files like index.html, about.html, and more, which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. This is model file which contains algorithm information which will be loaded into the project code during runtime. This is notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. This is signup.db file. This file is the database file used to store user information. And here, these are the dataset folders. So here in this folder, the dataset is split into train and validation. In the train folder, we have the images folder as well as the labels folder. In the images folder, we are having the images for object detection of remote sensing image. And all these images are used to train the YOLO V5 model. So here in total, we are having 802 images. And here in the labels folder, we will have labels or annotations for objects in the corresponding images. So each label file corresponds to an image file in the images folder, providing details about the object's locations and classes within the image. These label files often follow the YOLO format, where each line represents a detected object. Each line specifies the object's class index followed by its bounding box coordinates normalized to the image dimensions. So here these are the labels for the images which are present in the images folder. And here in the validation folder, we again have the images and the labels. In the images folder, we have the images which are used to evaluate the performance of YOLO V5 model. And here we can see we are having in total 200 images. And this is the labels folder where we will have the files containing annotations or labels for objects in the corresponding images. So each label file corresponds to an image file in the images folder, providing details about the project's object's location and classes within the image. These label files often follow the YOLO format, where each line represents a detected object. Each line specifies the object's class index followed by its bounding box coordinates normalized to the image dimensions. And here we have the readme.dataset text file and readme.roboflow text file. And here, this is the dataset folder in which the dataset is split into train and validation. In both these folders, we will have the images folder as well as the labels folder. In the images folder, we will have the images which are used to train the YOLO V8 model here. And in the labels folder, we have the labels or annotations for the images which are present in the images folder. And in the validation folder, again, we have the images folder as well as the labels folder. In the images folder, we have the images, and in the labels folder, we have the labels for those images. And these images are used to evaluate the YOLO V8 model. And here we have the readme.dataset and readme.roboflow text documents. Now we need to copy the path of the code folder from the address bar of the file explorer. So here I'm copying the path. Now open the Anaconda prompt. Use the cd command followed by a space and paste the copied path and hit enter. This command is used to change the current directory to the code folder's path. Compile the app.py file using the command python space app.py. So here I'm typing python space app.py and hit enter. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address. Localhost, which is this, and port, which is this. Now copy this local link provided by the Flask framework. I'm copying the link and paste this copied link into any web browser. I usually prefer Google Chrome and hit enter. The homepage of the project is displayed in the browser. This is the front end built using Flask framework. If we are a new user, we need to register first. So click on sign up button here. So here we need to register all these details. To register, but I have already registered. So click on sign in. So here we need to enter the username and the password, which are static, and then click on login. We have logged in successfully and we are redirected to the prediction page. So here we need to upload the images, and after uploading the images, the application will detect the objects of remote sensing imagery. So click on choose file to select the images. So here from the test cases folder, I'm selecting the third image. Now click on open. So here we can see that the image is uploaded. Now click on upload button here. So here we can see that the objects are detected. So here we can see that the people are detected with the yellow color bounding box, and on top of the bounding box we can see it is written people along with the probability score, which tells us the confidence level for the detection. So here we can see yellow color bounding box detecting people, and here we can see a bicycle is also detected with the red color bounding box, and on top of the bounding box it is written bicycle. So here we can see two bicycles are detected with the red color bounding box, and people are detected with the yellow color bounding box. Let us upload some more images. So click on detection link here. Now click on choose file. So here I'm selecting this image. Now click on upload button. So here we can see that the people are detected with the yellow color bounding box, and on top of the bounding box we can see it is written people along with the probability score, which tells us the confidence level for the detection. And here we can see a bicycle is also detected with a red color bounding box. And on top of the bounding box, it is written bicycle along with the probability score, which tells us a confidence level. Let us upload some more images. Click on detection link. Now click on choose file. So now I'm selecting this image. Click on upload. So here we can see there are so many objects detected. So here we can see that all the vehicles are detected. So here we can see these are the cars detected with the orange color bounding box. So here we can see all the cars which are detected. And here we can see a van is detected with a green color bounding box, and on top of the bounding box it is written as van. So here we can see 3 vans are detected and many cars are detected, and here we can see people are also detected. And we can also see that some bicycles are also detected with the red color bounding box, and on top of the bounding box it is written as bicycle, car, van, and people. And for all the objects detected, we have the probability score, which tells us the confidence level for the detection. So here in this remote sensing imagery, we can see that many objects are detected. Now let us upload some more images. Click on detection link. Click on choose file. So again, from the test cases, I'm selecting this image. Now click on upload. So here, this is the image which I have uploaded. And here we can see that all the objects are detected. That is, we can see that the vehicles are detected. So here we can see that the cars are detected with the orange color bounding box. And on top of the bounding box, it is written as car along with the probability score. So here we can see many cars are detected with the orange color bounding boxes. And here we can see a van is also detected with the green color bounding box, and on top of the bounding box it is written as van. And we can see a bus is also detected with the dark orange color, and on top of it it is written as bus along with the probability score. And the probability score tells us the confidence level for the detection. Let us upload some more images. Click on detection link. Click on choose file. So here I'm uploading this image. Now click on upload. So this is the image which I have uploaded, and here we can see that the objects are detected with different color bounding boxes, and on top of the bounding box the name of the object is written along with the probability score. So here we can see that the bicycles are detected with the red color bounding box, and on top of the bounding box it is written as bicycle along with the probability score, which tells us the confidence level for the detection. And here we can see that the cars are detected with the orange color bounding box, and on top it is written as car. So here also we can see a car is detected, a car. And here we can see a truck is detected with a green color bounding box, and on top of the bounding box it is written as truck along with the probability score. We can also see that people are detected with the yellow color bounding box, and on top of it it is written as people. And a bus is also detected with the orange color bounding box. So here all of the objects are detected in the remote sensing imagery. Now let us upload some more images. Click on detection link. Click on choose file. Now let us upload the images from the data set, from the train folder, from the images. So here, this is the image which I'm selecting. Click on open. Now click on upload. So here, this is the image which I have uploaded, and here we can see that the cars are detected with the orange color bounding boxes, and on top of the bounding box it is written as car. And we can see a bicycle is also detected with a red color bounding box, and on top of the bounding box it is written as bicycle along with the probability score, which tells us a confidence level for detection. And here we can see a truck is also detected with a green color bounding box, and on top of the bounding box it is written as truck. So in this way, just by uploading the images, we can detect the objects using the bounding boxes of different colors. Let us upload one more image. Click on detection. Click on choose file. So here, this is the image which I'm selecting. Now click on upload. So this is the image which I have uploaded, and here we can see many objects are detected, and we can see that the cars are detected with the orange color bounding boxes. So many cars are detected, and here we can see a bus is also detected with a dark orange color bounding box, and on top of the bounding box it is written as bus along with the probability score, which tells us the confidence level for detection. So here we can see most of the objects detected are car here. So in this way, by uploading the images, we can detect the objects of remote sensing imagery based on multi-scale feature fusion and attention mechanism. Now click on graph link here. So here, this is the precision and recall graph of YOLO. On the x-axis, we have recall score, and on the y-axis, we have precision score. And here, this is the F1 confidence curve graph. On the x-axis, we have confidence score, and on the y-axis, we have F1 score. And here we can see the different classes, the different objects which are detected. And this is the confusion matrix of YOLO. And here we have the comparison graphs for precision, recall, and MAP. Now click on sign out button here.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.